here is where you need to hold your breath. Will the projector work today? Well, what happened yesterday, I was teaching here, and I have to sit and enter things here, and then I move over here. Well, when I did that, I don't know why, but this little handle here somehow caught the cord going from projector to this and yanked everything off the table onto the floor, and nothing has worked quite right since. It completely destroyed the cord, which I thought would have been, it works fine. So, knock on wood. Okay. So, we're okay. I had to get a new cord, and the only one I could come up with, it wouldn't plug into the wall until I got neat little pliers and bent and twisted and yanked and turned. Finally, I got it in. I don't think you'll ever get this out if it ever goes bad because it's jammed in there so tight. It'll probably pull the box off the wall if you try to remove it.
What's the orientation of college teaching?
What's that?
What's the name of the orientation of college?
Yeah, that class?
Anthony.
Oh, Anthony, Elijah Anthony. Yeah. Pretty good. Yeah. He used to be full-time here. He retired, and he comes back and teaches that for us.
That's why I don't pull your butt.
What?
I guess because he's not like completely in the system all the time.
All right. Okay, we are recording. Oh, that's what I was going to do. Let's go over just a few announcements. I wanted to have this recording so people who are not here can hear these too. This is the end of Cougar Connection Week, basically. There is one event next week that they tried to schedule this week, and it's the blood drive, so watch out for that. But today is officially the end for the on-campus stuff, except for the blood drive. And both of the events today are on the Birmingham campus. The first one's on the Birmingham East campus, the second one on the West. This afternoon will be the Student Organization Induction Ceremony. This will be on the Birmingham East campus, A.G. Gaston Auditorium, and that starts at 1 o'clock in the afternoon. Okay? So they're your ambassadors, they're your Student Government Association leaders, they're your representatives on some of the other clubs and organizations. Feel free to go and participate in their induction ceremonies. I think you'll find it's quite nice, and there's usually a little bit of food there. Okay, so that should get college students there. And again, Birmingham East Campus, A.G. Gaston Auditorium. A really nice old auditorium there. You'll like it there too. Then, that's at 1 o'clock. From 4 to 6 o'clock, there will be the official end, sort of, to the Cougar Connection Week, a pool party. Now, where's there's a pool? It's an indoor pool. Of course, where would you expect that? In the Arthur Shores Fine Arts Building. Okay? Well, that's the Fine Arts Building. It's also our gymnasium. It's also the weight room. It's also the indoor pool. And it's a very nice facility. You don't have to go swimming unless you want to. Water will be fine because it's indoors. But I'm sure there's going to be good music. I'm pretty certain there's going to be some good food, and it'll be a good time. So that's 4 to 6 this afternoon, and that's Birmingham West Campus, Arthur Shores Fine Arts Building, the pool. Okay? Now, that kind of winds it up. But a little more information about, come witness the installation of your Student Government Association officers, the Lawson State ambassadors, as well as induction members of the Phi Theta Kappa Honor Society, Kappa Beta Delta Honor Society for Business. The guest speaker for the induction ceremonies is Mr. Galvin Billups. He's Executive Director of the Mayor's Office Division of Youth Services for the City of Birmingham, and that will be this afternoon, 1 o'clock, A.G. Gaston Auditorium. It'll be worth it just to go hear him speak, because I think he's quite good. Okay? Now, I don't know where y'all are in the process of how close you are to graduation. Any of you anywhere close? How close? Next semester. This term. Okay. Good news for you if none this term, because today's the deadline to get the application in for fall.
Oh, my boy Walter, I think he said he graduated this time. First.
Huh?
First.
Okay.
I think Walter said he did.
Are you graduating this term? No. Okay. But you say Walter is. Do you have a way to get in touch with him if he doesn't show up today?
You told too that, remember?
What's that? Okay, yeah, he was here too. Yeah, he was here. Okay, so he heard. Okay. So anyway, for those who are graduating next term, this is the best time to apply to graduate. Okay. Anytime between now and when we start registering for spring term, because the first thing you do is a degree audit. Okay. Basically, you get your degree plan. You take it into your advisor. The two of you go through that, see if there's anything that you are lacking that you need to graduate. Okay? If there is, okay, then you have time to register for it in the spring term. Now, if it's not offered in the spring term, then you still have time to get in touch with the department chair or the instructor who normally offers that course and see if they can add it to the spring schedule. Okay? If they can't, you have time to do a course substitution. See if you can find some course that will substitute for that is offered in the spring. So you can get all that stuff worked out before spring term ever begins. So then you know you're taking exactly what you need to graduate in the spring. You don't want to wait to apply in the spring and then find out, hey, I'm missing a course, and it's too late to get it on the schedule. Okay? So do what you can to, if you're graduating this term or next, get that application in soon. And the application is all online. It used to be a paper copy. Now it's all done online. Okay. Now here are two other opportunities. I think I announced these last time. One is for note takers. Did I announce that last time? Okay. And the other is for peer tutors in math, English, biology, computer science, and Spanish. I have a feeling both of these opportunities right now are on the Birmingham campus, but it's easy to get there, okay? But they do sometimes need the same things here on this campus. So please check. In fact, on this campus, not only the Space Center hires peer tutors, but the Student Support Services also hires peer tutors. So there's plenty of opportunity there. To help a fellow student, you help yourself by, especially when you tutor, you learn the material better, and you get paid for either note taker or peer tutors. Okay. Any questions before we get going today? Any questions on anything we've done so far? All right. Now, my note in my book has us starting at example 4, but the slide says example 5. So I have a feeling they didn't do 4 in the text. So let me get set up from the current slide. And let's go back and see. Yeah, it doesn't look like example 4 is on here anywhere. So let's do example 4 before we do example 5. Okay? Ooh, let me get my pen set up. Okay. Now we started this one, didn't we? If I'm not mistaken, we did start this, but we didn't get too far on it. Here's our, you might say function. Y is equal to 1/2 times the sine of x minus pi thirds. Okay. Now, in my mind, it's best to start identifying your parameters, figuring out what they're going to tell you. What parameter do you see first? 1/2. What parameter is that? Okay, that's your A is equal to 1/2, and the absolute value of A, which is 1/2, is your amplitude. Okay, that's your amplitude. What do you see next? And you may not see it, but it's still there.
B is 1.
And B is 1. You don't see a 1 because you don't usually write it, so B is equal to 1. What does that refer to? Period. And how does it relate to the period?
The period is 2 pi over B.
Yeah, it's 2 pi over B, and since B is 1, it's just 2 pi. Now, once you know the period, what do we always do? Divide it by 4. So the period divided by 4 is what? Pi halves, okay? Pi halves. Perfect. Now, that's going to be, that would normally be my increment, okay? Because that's usually what I use. Except in this problem, we have also a what? C is equal to what? Pi thirds. You're absolutely right. It's not minus pi thirds because what follows the x is always a minus sign, so your C is what follows the minus sign. If that was a plus, then the C would be minus pi thirds. It's a minus, so it's plus pi thirds. Everything dealing with x's is backwards, okay? Remember that. Now, since and what that tells us is our phase shift, okay? We're going to be shifting our starting point, the x, not at 0, but at pi thirds. Well, that then changes everything. Well, changes some things. Normally, we'd be increments of pi halves, but pi third and pi halves, they're not common. So we have to find an increment common to the two, and that would be what? Pi 6. So that's going to be our increment for this problem. And it's a little unfortunate, but life is sometimes unfortunate, okay? So here is going to be our graph. And I'm going to just tick off 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Negative 1, 2, 3, 4, 5, 6, 7, 8. Okay? And we'll go up. Basically, I'll go up 1 and down 1. But we don't need that because we're only going to plus or minus 1/2. Because our amplitude is only 1/2. Okay? Now, remember these are pi 6. So pi 6. Pi thirds, pi halves, pi. Oh, Jake decided to do it. Good deal. I don't know how you come from the Birmingham campus, but the way I go, sort of a back way, you can't really speed too well because one of those little towns in there is notorious for having cops out. So I know you try to get here, but be careful doing it. Okay. 1, 2, 3. I'll put 3/2 pi. I'll end it there. And this is minus pi 6, minus pi thirds, minus pi halves, minus pi, and so on. Okay. So everything is going to be stretched out because we had to expand our scale somewhat to get everything in. So, on this one, where we begin is our phase shift. That's the pi thirds. So this is going to be the starting point. Where does sine usually start? At 0. So we'll have our 0 right there. Now, where is it that you'll have your first key point for sine? Pi halves from there. But since you're measured in 6, pi halves is 3 pi 6, right? So count over 1, 2, 3, and that's going to be your maximum at 1/2. And then another 1, 2, 3, and that's your next 0. And then another 1, 2, 3, that's going to be your minimum down here at minus 1/2. So that's how you do. We had to do our increments in pi 6 because it was the least common denominator between pi thirds and pi halves, but we locate the pi thirds, which is our starting point, and then we go right or left. We haven't gone left yet. Your increment, which is pi halves, which is 3/6 pi's. So 3 of those every time. So let's go to the left. 1, 2, 3, and that's going to be a minus pi 1/2. 1, 2, 3, that's going to be back up at 0. 1, 2, 3, up at positive 1/2. So here is how our function looks. That's it. Now that's a little over one cycle, because I sort of spread it out to get in our phase shift and our increments and have them make sense. Does it make sense to you? Any questions about any of that? Got it? Okay. Believe me, on the next test, you're going to see some graphs, okay? First test didn't have any graphs on it that I recall, but the next one, got big time graphs, okay? Most of the first 2 sections here are graphing, okay? So that was our horizontal translation, and if you look at the one in the text, the figure in the text, you see very similar to what we have. They did compress the X scale a little bit more than we did. I got more on the negative side, they got more on the positive side. Okay. And there's a checkpoint there, and audio-video solution for the checkpoints at English and Spanish at larsonprecalculus.com. No code necessary, no access code. You just go there, free website. All right. Now we're ready for example 5. So I'll clear this if y'all don't have any more questions on example 4. Okay? So let's go to example 5. And that one is here, so we will be able to do part of this. Sketch the graph of negative cosine of 2 pi x plus 4 pi. Okay? Now, I've already indicated to you I really don't care for the way the book does these, though it's perfectly correct. I like to do them slightly differently. Okay? So I'm going to show you my preference. You don't have to do it. You should get the same answers either way, but I'm going to show you the way I prefer to do this. Okay? I'm not going to change anything here. Minus 3 stays minus 3. Cosine stays cosine. Okay? Not changing there. But what I like to do is pull the b out of the parentheses. Okay? And what is your b in this case? More than that. 2 pi. So pull that out of the parentheses, and what does that leave you with? X plus, oh, you pulled the 2 pi out. No, you pulled 2 pi out. Okay, but you factored out a 2 pi. No, not 2 pi. 2, got it, all right. Now, and this is sort of a strange problem, okay? And to me, it makes more sense to think of it this way. The way I do it this way, 2 becomes your phase shift. The way the book does, you have to say 4 pi divided by 2 pi becomes your phase shift, which is exactly what we did, but you have to do that manipulation to it. I like to pull the 2 pi out to begin with. That's your b, still your b. It was your b, still your b. Now your c, the way I refer to it, the phase shift is 2. The way they do, the phase shift is c over b, which makes it awkward. I like to pull it out and make the c be my phase shift, 2. Okay. Now, let's identify our parameters. Now again, remember, I'm doing it slightly different from the book, but you should get the same answer. What's your first parameter you happen to see? A is equal to negative 3, and what does that imply to you? Amplitude is equal to what? Which is? 3. Perfect. Next parameter? Next parameter? Help me, help me.
B,
B is what?
2 pi.
2 pi. And that makes, what does that relate to?
The period.
The period. And what does that make the period? 1. Very good. Now your C, which my C is the phase shift. Okay? This is the phase shift. And that phase shift is 2. Okay? Now what do we normally do with the period once we know it? Divide by 4. So period divided by 4 is what? 1/4. And your phase shift is 2. Oh wait, no, I didn't quite get that correct. What did I miss? What I told you before on the last one, the C is always the thing following the X. It's -2. Very good. I almost blew it there. C is -2 because everything dealing with the X is backwards. So that is -2. It's really X minus a -2, so that makes the phase shift -2. Okay? Sorry, I almost blew that. This is X minus a -2. So the C is -2. All right. All right. Now that we've got that, we can draw our graph. All right. Now, we're going to have increments of 1/4. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. -1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we're going to go up 1, 2, 3, and down 1, 2, 3, because our amplitude is 3. Okay. Where do we begin? Oh, let me put these in. This is 1/4, 1/2, 1, 2. This is minus 1/4. I'm so used to saying pi, I can't help but write it. Okay, minus 1/4, minus 1/2, minus 1, minus 2, and so on. Okay? Where do we begin?
At the amplitude.
Not yet. X, where do we begin? At the phase shift.
2.
Yeah, because that's right. Yeah, at -2. Remember, we changed it to -2. We start way over here. And what is cosine? Where does it begin? Normally. Cosine normally begins at? Okay, and what is? Well, not quite on this one. It begins with whatever your A is, and it begins at -3. That's where it begins. It normally would begin at 1, but then you're multiplying the 1 by -3, so it begins down there. Now, every increment now, you're going to have another key point. So it goes to 0, it goes up to +3, down to 0, down to -3, up to 0, up to +3, down to 0, down to -3. Look at that. It's right where it should be there. We could have started there, but we didn't know that at the time. Up to 0, up to +3, down to 0, down to -3, up to 0, up to +3, down to 0. It gets tedious, doesn't it? But this is how it works. Periodic functions do like this. We could go back here to a 0, and up here to a +3, down here to 0. So it does something like this. Now, I'm probably not drawing mine too well, partly because I got a little stretched on my x-axis over here and got sort of shrunk over here. So it doesn't look right, but if you can just imagine if those are all equal increments, that would look better. The other thing I have to be careful for, especially like down here, you always have to make sure these are rounded here. Don't have them pointed. That one's too pointed. It should be rounded, 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 rounded. all the way. Okay? I don't quite intersect the points well, but that's my bad too. That's how it looked. The first period is from here to there. Okay? Goes up and down. Okay? Not over there where it normally would be, because of your phase shift. It starts at -2. And the y starts at -3, because that's your a, which is -3. Does that make sense? So you see, figure out your parameters, figure out the meanings of those, what they imply, and I like to factor out the b before I start dealing with phase shift. What the book does, leave it like it did, but then have the phase shift as being what they call c, 4 pi divided by b, which is 2 pi, which comes out 2. And they get the same graph. Everything's the same. It's just what they call the phase shift. Well, I like to call c the phase shift. They call c over b the phase shift. But I just go on and divide out the b first. All right. Any questions on that? That was example 5. As you see, theirs looks a lot like mine. Maybe not quite as pretty, but close. There is a checkpoint there, well worth your effort to do the checkpoint. All right. Oh, wait. I forgot. They showed this one, so let's see how they do it. All right. Now, theirs, they didn't identify A, but they went straight for amplitude 3. The period is 2 pi over 2 pi, which is 1, exactly like you've discovered. Now, by solving the equations, see, they go through all this. And to me, if you just first do the period, then do a quarter period, and then go from there, all this is taken care of. And you don't have to do the solving the equation. But if you understand this, by all means do it. Okay? So the 2 pi x plus 4 pi, set that equal to 0, because that's normally where cosine begins at 0. And that now has x being -2. So that's where you're going to be starting. Same way we did it, except I didn't solve that equation. As soon as we saw that the the phase shift, if I factor it out, it's going to be a 2, x plus 2, but it's always of the form x minus c, so c had to be a -2. So we got there the same way, but to me their way is, I just don't, I find it more, I have to think, now what are they doing next? Okay. And then they go to 2 pi will be the next one, and when you do that, you get 2 pi x equal -2 pi, which again is sort of crazy. I mean, it's fine. X equal -1, so that's going to be the next interval. That's where it begins, at -2, -1. Starting at -2, going to -1, that's one complete cycle, okay? Which you wind up with anyway, the way I do it as well. So dividing that interval into 4, and they wait till now to do it. I've already done this. Jalen's here. So we're only missing Walter and Gavin. Okay. These are your points, but you see if you just line them out and identify your starting point, and then every point on your interval, you decided your interval was b over 4, which is 1/4. Then for every interval, you put another one of these. Starting at the min, going intercept max, intercept min, intercept max, intercept min. You can do them all. You don't have to list them. But you can. If that helps you see it, go for it. Fine. Perfect. Okay? Now, here is the figure, and that's pretty much like we showed. I think theirs are rather pointed too, but they are rounded. But just barely. Okay? Because they have a pretty compressed x-axis. You're going from -2 to -1, that's one period. I pointed that out to you before. Your next period starts here, and that looks the same way as this, and it is, because it's periodic function. But this is technically the first one. That's when your x is equal to 0. That's where you're going. All right, does that make sense? Get used to graphing these, but like I said, your next test is going to be almost vast majority of the front page of your test is going to be graphing. Okay. All right, the final type of transformation is a vertical translation. Okay? Your A wasn't really a transformation, it's just a parameter that dealt with the amplitude. The B wasn't a transformation, that was, well, it sort of indicated one. That was your, well, actually A was sort of one. If you think back to pre-calculus algebra, that A in front was basically your vertical stretch or shrink, depending on the size of A. The B was a horizontal stretch or shrink, depending on the size of B. The C was a horizontal shift, right or left. The D is a vertical shift, up or down. Okay? That's exactly what these are here, only we call this amplitude, we call that related to the period. Okay. The shift, this is now a shift D units up to D greater than 0, D units down if D is less than 0. In other words, the graph oscillates about a horizontal line, y is equal to D, rather than about the x-axis. We're used to everything being on the x-axis, but when you have a vertical shift, you move the equilibrium line, is what I like to call it, up or down, depending on what the sign of D is. And then you go to everything from there. So, they tell you all that and don't show you any of it. Okay, so let's back up and do example 6. Now, they only have one of those. And if I didn't mention it before, there was a checkpoint. Wait. A checkpoint following, yeah, I did mention it, example 5. So let's do example 6. Let's go back. This will probably be a good place for it. Let's do example 6. Sketch the graph of y is equal to, and why they put the 2 in front, I'm not really sure, but I sort of have a clue. 2 plus 3 cosine 2x. Okay? What's usually the first parameter we look? Okay, the A. The A is 3, which in this case, because that is its absolute value, it's also the amplitude. So you're absolutely right. What parameter do we investigate next? And what is your B here? That B is 2. And how does that relate to anything? Second? Okay, how does it relate to the period? 2 pi over B, so it'd be 2 pi over 2, which is pi. I like that sound of that. Okay, what's your C here? That's D. C is 0. You have no phase shift.
What was the question again?
I'm sorry?
What was the last question you asked?
C, what's your C? You don't have a C. C is 0. If this had been 2 pi plus or minus something, 2x plus or minus something in parentheses, that would have represented the phase shift. C is 0, so you don't have a phase shift. And then your D is 2. And that's a vertical shift. A phase shift is a horizontal shift. A vertical shift is what your D represents. Okay? That tells you where you move your equilibrium line up to. Just don't say yours. Okay? So, we did the period, but I forgot to do what your quarter period was. What's your period divided by 4? Is pi divided by 4. Since there's no phase shift, that will be our increment. Okay? So let's do, let me correct that. I'm going to put my line down here, horizontal axis. The reason, we have a vertical shift and it's upward, so I wanted to get that covered. Okay, there's our horizontal axis. I'm going to make an increment of pi fourths, so that would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Negative 1, 2, 3, 4, 5, 6, 7, 8. And we're going to be going up at least 5. 1, 2, 3, 4, 5. And down at least. Okay. Oh man, I didn't get much of a break between classes, and I'm feeling it now. I needed to drink more water. I stopped and got one swig at the water fountain, but that wasn't enough. Because I talked an hour and 15 minutes in that class and already well on the way on this one too. So let's go. Where do you begin? Normally. Normally, where do we begin?
Begin at the origin, at whatever the amplitude is.
Okay. Well, okay. Yeah, okay. Because this is cosine, you're right. But let's think of it this way. Normally, we begin at the origin because things start there. But if you have a phase shift, you move there. Well, we have no phase shift, so we're still at the origin. Except we have a vertical shift of how much? 2. So actually, we're going to start up here. So our new equilibrium line is here. Okay? And we need to tick off our points on that equilibrium line. Get out of there. Okay. Okay, that's where we need our equilibrium points at on the our interval points on the equilibrium line. Now, I didn't write them in; they're pi fourths, so I'll put them in down here. But we'll refer to them as they're pi fourths, pi halves, pi, 2 pi, minus pi fourths, minus pi halves, minus pi, minus 2 pi. Okay, but we're actually go for the ones of the elevated line, our equilibrium line. Okay, now from that line, that's where we begin now. If there was a phase shift, we would begin there. There's a vertical shift, so we begin up there. And now, as you said before, you go to your amplitude. And that's 3, and it's 3 up. So you go 3 up from here, 1, 2, 3. There is your first point, because cosine starts at the max point, amplitude. Then we go down to 0, and down 3 below your equilibrium line, which gets you down here to minus 1. Then back up to 0, back up to plus 3, back down to 2, and back down to minus 1. Back up to your equilibrium line, and back up to 5, which is 2 plus 3, and down to here again. Okay? Going backwards, you do equilibrium, minus 1/2, equilibrium, oops, I didn't go high enough right there. Whew. All right, back down to equilibrium, back down to your minimum, back up to equilibrium, and back up to your maximum. And go like that. So here is your graph. It's hard to see where my points are because there's so much written on the same scale. Okay, there it is. A vertical stretch, that's what your amplitude is. A horizontal shrink, okay, because because you have a 2x. If you think about it, normally one cycle is between 0 and 2 pi. Now you have one cycle between 0 and pi. So that's a horizontal shrink. And then there's no horizontal shift. The phase shift is 0, but there is a vertical shift 2 units up. So you do your initial point is 3 above, because that's your amplitude, 3 above your equilibrium position, which is at 2. So you're up there at 5 to begin, and then go 3 below the equilibrium position, which is at 2. That gives you -1. So that's how you go back and forth between those. And you use your increment to be your quarter periods. Okay. Any questions on that? All right. And they didn't show this in the text. Well, I mean, on the slide set. But it is in the text. And if you'll follow that. Okay. My goodness, I need something to drink. Let's move on. Any questions on that before I erase it? Okay. There was example 5, which we had already done. Now we're going into mathematical modeling. Okay. Runway, please. No, never mind. Okay. And this table shows the depth in feet of the water at the end of a dock at various times during the morning, where t equals 0 corresponds to midnight. And this is one particular day. At midnight, the depth was 3.4 feet. At 2 o'clock, it was 8.7 feet. At 4 o'clock, it was 11.3 feet. 6 o'clock, 9.1 feet. 8 o'clock, 3.8 feet. 10 o'clock, 0.1 foot. And 12 o'clock, 1.2 feet. Okay. Now, what we have here, what they do first is plot this on a graph, which certainly is a good idea. It's not absolutely necessary, but it is a good idea. Now, one of the little problems here is that you're not absolutely sure that you're at the peaks and the valleys. You may be off, but you have no way of knowing that. So you have to kind of make an assumption that the maximum value here is going to be a max, and that the minimum value here is going to be a min. Not much other way you can assume that, okay? So you have to kind of make that assumption. And when they drew their graph, they made it fit that way. You made it that. I mean, when I look at this, these data, it looks like to me that the maximum you probably is a little one side or another from here, because this was a lot lower than this, so it seems like the max might have been back this way a little bit. Same thing with the min here, because the 3.8 is a great deal more than 2. You're not right on it. You know, you probably need to be a little bit shift. I would say shift everything down a little bit. But we have no way of doing it, so we're just going to have to assume those are indeed our max and min. Okay. And it's not bad. It's not a bad way to do. Okay? They haven't told us what to do yet, but I wanted you to sort of focus on these data for a little bit. So we've got to come back and think about them later. Okay? Now, here's what the problem is. Use a trigonometric function to model the data. Okay? Now, what trigonometric function do you think would come closest to modeling that?
a secant or a.
Okay.
Because it goes up above 1.
Okay, yeah, okay. But think about that last thing we did. We had a positive phase shift upward, vertical shift up. That can account for that. A secant goes to infinity. None of these depths are going to infinity. So, in fact, all your secant, cosecant, tangent, and cotangent go to tangent. They go to infinity somewhere. So those aren't good models. This is either going to be a sine or a cosine. Okay? Now, you get to choose which. Okay? Now, so, if you had done the graph, which they don't show, I'm surprised they don't show it here. Let me just make sure they don't. Yeah, there it is. There it is. Okay. To me, this looks a bit more like a sine than a cosine. But you have a phase shift. The phase shift is over here somewhere. Oh, no, I'm sorry. Not true. Here's the max, there's the min. Your equilibrium line is somewhere exactly halfway in between that. So it's right there. So this is still even closer like a sine going up from that. There is a little bit of a phase shift here. And there definitely is a vertical shift, okay? But otherwise, this is going to be pretty close to a sine. Now, the interesting thing is the book does cosine. And it really doesn't matter. Either one will work. It does well. Either one of them. Okay. Now, like you see in the graph here, we're assuming that's the max, you're awfully close to it, and that's the min, are awfully close to it. Okay? Seems like to me the min should be over here a little way because going back up. Yeah. But they don't do it, they don't assume that's the min. So that's where we need to begin. What parameter relates to the difference between the max and the min? Okay, and which parameter would most document that?
Amplitude?
Yes, exactly. The amplitude, how is it related to the difference of the max and the min?
It's the absolute value.
Okay, it's the absolute value of your A. That's what your amplitude is. How does that relate to the difference between the max and the min? Because the amplitude, think of it.
Does it increase or decrease?
Right, okay. Think of this. There's your equilibrium line somewhere in here, right? Your amplitude is how far above or below that is. So this, between here and here, is twice the amplitude, right? Okay. So the difference between the max and the min is twice the amplitude. So let's start with our A. That's a good place to do it. Let's go back to our graph. The max here is 11.3. The min is 0.1. So the difference between those, 11.3 minus 0.1 is easy math, 11.2. And half of that is your amplitude. So divide that by 2, and that gives you 5.6. That is your A. That is your A, your amplitude. It is an amplitude is A. Now, while we're doing that, it probably is not going to be a bad idea to figure out what the D is. I keep saying it, is somewhere around there. How do we nail it down? What is our D? What is the distance above the x-axis that your equilibrium line has been shifted? Okay, well, the amplitude is involved with it, but how far up is your equilibrium line? Where is your equilibrium line? It has to be equidistant between these two, right? Now, take the average of those two. 11.3 plus 0.1 divided by 2. That's the average, right? And what would that give us? $5.7. That's your D. Your A is 5.6. Your D, the vertical shift, is 5.7. Okay? Now, that's vertical stuff. Your amplitude and your D. Now let's fiddle with the horizontal stuff. Okay? Now, especially if we're going with the sine, we need to see where this graph crosses your equilibrium point. That would be your starting point. Okay, where on the X or the T in this problem, you would be here. Well, it's something between 0 and 2 o'clock, right? 2 a.m. 5.7, you would be something in between those two. So we need to do sort of a extrapolation type thing or something like that to see exactly where that would be. Well, wait, no, that's not quite right. Time out for that. Okay. Here's your max. Here's your min. The max is at 4, the min's at 10. So what's the time difference between those? 6 hours. And what's exactly in between your max and your min? Yeah, that's going to be your equilibrium. So that's going to be what sort of corresponds to half of a period, right? If you're starting with sine, you're going to be back there half a period. So half your period would then be, what do we say, between 4 and 10? So that's 6. 3. So at 3, 3 past 4, okay, or 3 before 4, that's going to be, So we would have it being at 1 o'clock. We said between 0 and 2, exactly at 1 o'clock. That would be your phase shift, what I call the C, okay? So the C, the way I call it, C, is going to be 1 o'clock, okay? All right. B. We haven't done B yet. All right. B relates to what? Period. And we've already said half a period is 6. So one full period would be 12. And guess what? Your tides go in 12-hour periods, don't they? Okay. So your period is 12. Well, how does period relate to B? The period is 12, T equal 12, and what would your B be? How does B relate to period? Period is 2 pi over B equal 12, so we could multiply both sides by B and divide both sides by 12. So you got B is equal to 2 pi over 12, which is pi over 6. So there is your B. Guess what, folks? We can write down our equation right now. We said y is equal to, now I like to start with the A, they like to start with the D, I'm going to start with the A. It's 5.6 times the sine of B pi 6 times, I like to put the C into here, t minus 1 plus, and I'd like to put my D on the outside here, and that's 5.7. Okay? And your Y's and your 5.6 and 5.7 are all in feet, and your time is in hours, okay? T is in hours, but your pi 6 is sort of it's per hour type thing, so we don't have to worry about that. That's our rendition of it. Let's see what they got, okay? Well, do you want to go on and find the depths at 9 and 3? Or you want to go on and see how they did the trig function? It's up to you. Want to go on and do the B first? Sure. Okay. So 9 a.m., how would we figure that? Yes, exactly. So Y at 9 would be 5.6 times the sine of pi 6 times 9 minus 1, 8 plus 5.7. And by the way, what are we in? The T's in hours, but our trig function's in radians, always, unless you know otherwise. So let's simplify this and make that 4/3 here. And we might even be able to figure out what sine of 4/3 pi is. I think we can. Isn't that? Anyone know what sine of 4/3 pi? 1/3, 2/3, 3/3, 4/3. Second?
So 4 pi thirds?
Yeah, 4/3 pi. Yeah, 4 pi thirds. Third, I think. Yeah. So the sign will be negative either way.
Negative root 3 over 2.
Exactly, negative root 3 over 2. So 5.6 times a negative root 3 over 2, then add to that 5.7. And what do you get? Okay, if we did a root 3 over 2, 2 will go into that 2.8 times. So 2.8 times root 3 plus 5.7. What do you get? Oh, that's a minus though. So it's minus 2.8 times root 3 plus 5.7. What do you get? Minus 2.8 times root 3 plus 5.7. Anybody? Anybody? Minus 2.8 times root 3 plus 5.7. Anybody? Some of the calculators must be pretty slow. Nobody? Not even on a phone. It'll do all that stuff. I don't have mine in here. Minus 2.8 times root 3 plus 5.7. Woo! Shouldn't be. No, 2.8. Negative 2.8 times root 3 plus 5.7. 0.85. That should be the depth in feet at 9 in the morning. Well, let's see what our data show. We're something between 0.1 and 3.8. I think I can buy that. Don't you? That sure fits right in there. 9 o'clock would be something in between those two, and that sure is in between those two. Make sense? All right. The next part of it asks, though, at 3 p.m. Wait a minute. That's outside our data set. But we still should be able to do it. Y is equal to 5.6 times the sine of pi 6 times t minus 1. What are we going to use for t at 3 p.m.? What's your t then? Second?
Not just use t. 3.
I don't think so. Anyone know why? Because this is later in the day.
Oh, yeah.
This would be how many hours after midnight? You're not used to military time, huh? 15. T is equal to 15. So go back here and plug t is 15 minus 1 would be 14 plus 5.7. Okay? Now, again, we can simplify this a little ways. Make that 7/3, right? And 7/3 pi. Where are we, Waldo? Second? I think you're back in the first, aren't you? Because 1/3, 2/3, 3/3, 4/3, 5/3, 6/3, 7/3. You're back in the first quadrant. Which, by the way, I didn't want to agree with you, but since you are on 12-hour period, yeah, 3 would work just as well. But they didn't want you to use that. They want you to do this, okay? But yeah, 3 would have worked just as well. We'll see. Okay? So that is at back at pi thirds. What's sine of pi thirds? Root 3 over 2. So here's another root 3 over 2 here. And since your 2 will go into 5.6, 2.8 times. Again, you have 2.8 times root 3, but this time it's positive. Okay? And so 2.8 times root 3 plus 5.7. Same calculation as before, except it's a positive 2.8 times root 3. So plug that in, see what you get. 2.8 times root 3 plus 5.7. $10.5 what? Okay, let's make it 10.6 feet. And sure enough, 3 o'clock in the afternoon should be about the same as 3 o'clock in the morning. If your period is 12, then sure enough, that seems to fit like a glove. 10.6 feet. Okay? Now, here's a tougher one. A boat needs at least 10 feet of water to moor at the dock. During what times in the afternoon can it safely dock? Okay? Now, I was going to show you the analytical way to do it, and then I realized we haven't done inverse sines yet. So what they're going to do is do the graphical way. And basically what you do, knowing this is a 12-hour period, right? Or it's supposed to be, It doesn't quite look like it is, but basically it's going to be anywhere from here to there. Now, my lines probably aren't straight, but it looks like a little after 2 to a little before 6. Okay, that's just, and this would be in the afternoon if indeed this is a 12-hour period. And it's not quite. But what they do is enter the thing we just did, and then in the afternoon, and have them draw that, and then in the afternoon pick out those times. Now, and you have to have a graphing calculator to do that. Find the intersections of that. Not everybody has a graphing calculator, and they all don't work the same way, so I have a hard time teaching how to do that. If you know how to use your graphing calculator, use it, and get those. If you don't mind, I will show you how to do it analytically with the understanding we haven't done it yet. So you want to do that? Well, that would be a little awkward. So let's just do it that way. So let's just say it's, we'll just look at the answers they get and see if it agrees with what I sort of drew in here. Okay? Now first, it says you can use either a sine or a cosine model. Suppose you use a cosine model to do this. Well, I used a sine model. And look where they did their plus D. They put it at the end, which I thought was a reasonable place to put it. But let's see if we come up with the same thing. Your A is 1/2 of the difference between the maximum depth and the minimum depth. Just like we did, okay? And they found that to be 1/2 of 13.3 minus 1.1. That's 11, that's 5.6. Just like we did. And that has to do with the amplitude, okay? And that's exactly, it would be the same amplitude for sine or cosine. So that's perfectly fine, okay? The cosine function completes 1/2 of a cycle between the times where the maximum and minimum depths occur. So they're going to do the period now, which we did, and period is 2 times the time of the minimum depth minus the time of the maximum depth, and that's 6 hours, so that was 12, which implies that the B is 2 pi over P, which is 12, 2 pi over 12, and rather than doing pi 6, they estimate it to be 0.524, which is not bad, but why do that? Why not use pi 6? We know how to deal with pi 6, okay? So they deviate there a little bit, okay? Because the high tide occurs 4 hours after midnight, consider the left endpoint, your B, C over B to be 4, so C is about 2.94, which is an awkward way to do it, but it's okay. If we had been doing this, we would have used the phase shift as being 4. But we did sine, so we had the phase shift of 1. Moreover, because the average depth is 5.7, it follows that your D, your equilibrium position, is 5.7. So sure enough, they got the same parameters except for their phase shift, because they use cosine, we use sine. Came up the same thing. Y is equal to 5.6 times the cosine. I use pi 6, they use this fraction. T minus, and they use that. I factored out the pi 6, and we wound up with just a 1 there. Much easier to work with than the way they did it, but the plus 5.7. Okay, so when they plugged in 9 for 9 o'clock in the morning, they got 0.84 feet. What did we get? We got 0.85 feet. And that's because they rounded to a couple of places right here They rounded that. That's approximate. We use something exact. And then they also had approximate for C. We had exact. Okay? So they basically introduced the error. Okay? But it's same thing. 0.84, 0.85. Okay? Now, when we did 15, okay, they came up with 10.57. What did we come up with? Oops. 10.56. Okay? So, very, very close to the same thing. Yeah, they got 10.62, 10.57, 10.6. Can't get much closer than that. All right. And then using a graphing utility, that's how they did it here, did the line here, picked out the times of the afternoon when these would be, that would be 14.7 hours and 17.3 hours. That's two hours, about 2 2/3 hours, and 7 and 5 1/3 hours. So that was pretty much the same thing we got, okay? Maybe not right on the money. If you did those, 14.7 would be 242, and 17.3 would be 580. Now, you don't have to have a graphing utility to do that. There is another way, and we'll talk about that later. Are we running out of time? I see people packing up. Ooh, yuck. Yes, we are. But that did finish the section. There is a checkpoint, and they did find the sign model, and that's exactly what we did. So we'll start next time with vocabulary, if I can find my pencil, and then we'll move on to 4.6. Here's the homework exercises. Any of the odds 5 through 11. They're all at Calc Chat. Number 7's at Calc View. Any of the odds 13 through 19, they're all at Calc Chat. Then do any of the odds 21 to 23, either 21 or 23, they're also at Calc Chat. Any of the odds 25 to 29, they're all at Calc Chat. 27's at Calc View. Any of the odds 31 through 51, they're all at Calc Chat. 49's at Calc View. Any of the odds 53 to 57, they're all at Calc Chat. 55's at Calc View. Any of the odds 59 to 63, they're all at Calc Chat. Either 65 or 67, they're both at Calc Chat. 65's at Calc View. 69 or 71, or both, they're both at Calc Chat. 71's at Calc View. Do 73, the only one like that, and then any of the odds 75 to 77, either 75 or 77, they're both at Calc Chat. 75's at Calc View. 79 is a very practical problem, so I would say do any of the odds 79 through 85. Any of the odds 79 through 85, they're all at Calc Chat. There's a true-false, 2 of them, 87 and 89. They should be at Calc Chat. If you like to do a conjecture, it's at 91. There's a writing one at 93. Polynomial approximation, 94. You don't have to do any of those unless you want to. All right, good deal. Excellent. Way to go.
Hey, we have a game Tuesday.
Oh, too bad.
So,
Okay.
do you know what we'll be doing Tuesday? Like what chapter?
Yeah, we'll just be picking up exactly where we'll pick up at 4.6.
Okay.
And probably get most of it, but probably not all of it done. Okay?
Okay.
It's a little on the short side, but it's a lot of different things to do in it. So.
Okay.
4.6. It'll be on YouTube.
Okay.
Yes. Oh. Is all your payment and everything taken care of? Oh, it's not. Okay. Well, when I was putting in no-show report, your name didn't even show up, and it happened in one of my other classes. 2 people's names didn't show up, so when I asked them about it, they both were fully paid, so the system was screwed up. So I wanted to see if you,
No, I haven't paid yet.
okay, well, you need to get it done. Otherwise, they're going to remove you from the, well, technically they already have, but you're still on Blackboard, right?
Mm-hmm.
So they haven't taken you off that, but at some point they might. So before that happens, if you can
You know, if they got like a deadline for it.
Huh?
No, if they got a deadline or anything.
That's the thing. It's always a mystery to us too when they do that. Some terms they've already done it by this time. Other terms they act like they forget about it or something. But they've had people that right before the end of the term they realize they haven't paid, they remove them from the class, and then we can't give them a grade. In fact, right now I can't give you a grade because they only give grades for the full-time the other people have paid. So just get it paid
Okay.
before they mess up. I don't know when that's going to be. I didn't want to say anything.